Hi Kickstarter, I'm Connor.
And I'm Joel, and we're bringing you OpenBCI, an open source, low-cost EEG system for makers.
We want to lower the barrier of entry for brain-computer interfacing enthusiasts.
When you support OpenBCI, you get a Bluetooth-enabled EEG system for makers. It's going to have an Arduino on board, and it's fully programmable. But it's not just about EEG. Your body outputs all kinds of electrical potentials that we can measure with OpenBCI. So we're also going to be providing a biopotential suite for sensing ECG and EMG. That's heartbeat and muscle movements.
There's a lot of EEG platforms out there, but most of them are closed in some way or another. Either they do not allow you to put the electrodes where you want them to be, or the data is not accessible, and so it makes it very hard to do what you really want to do with the system.
To get started, you need a computer,
an OpenBCI board,
some cables and electrodes,
and a brain. First, download the OpenBCI code examples and libraries from our GitHub.
Second, upload the Arduino code just like you would any other sketch.
Third, launch the OpenBCI Brainwave Visualizer. It has been ported to a number of open source software platforms.
Fourth, apply the electrodes to your head and connect your brain to your computer with OpenBCI.
Then, see your brainwaves in real time.
So here we have the OpenBCI Brainwave Visualizer. It's connected to Connor's head. And right now you can see some eye blinks going by in the time domain spectrum here on the right. And we have an FFT plot on the left. A map of the electrodes, you can see the numbers corresponding to the waves here on the right. The two in the front are receiving most of the eye blink artifact. Connor, grit your teeth a little bit. You can see that the EMG artifact is showing up here across almost all the channels. So a good way of doing a test here with the EEG signal, making sure we got all the connections we need, is if Connor closes his eyes, which he's doing now, we should see a high frequency or high amplitude alpha wave, which is in the 10 Hertz band, which is what we're seeing down here on the FFT plot.
I think what makes OpenBCI different than what's currently available is that you have full access to the data, full access to the algorithms, full access to the configuration of the hardware. And this opens up so many possibilities to explore what can be done in the brain-computer interface field.
We see a variety of different people being interested in this, coming from different backgrounds. So, typically EEG and brain-computer interfaces are, at least historically, they were set in research and academic settings, but now there's this movement to bring the technology out of the academic setting, out of the research setting, and give it to just an everyday person. And so we see artists, creators, computer scientists just using this as more of a hobby thing than actually a research grade EEG, even though it's just as powerful.
I'm a neuroscientist, and I've been trained that way for the past 10 years. As such, my thinking about neuroscientific questions is, in a way, bounded. And the more people that you can bring to the table who are interested in the same questions, but who have different expertise, different training, different knowledge base, the more creative, new, innovative ideas you're going to be able to come up with.
We've been prototyping the hardware all summer long, and we really feel like it's at a point now when we can really start to share it. We're here at ThoughtWorks today with our first hackathon, bringing people together, software programmers, hardware engineers, people with general interest, to share ideas and help push OpenBCI forward to make it accessible for everybody.
As we're walking around, we're constantly labeling the world around us as interesting or uninteresting, things that you care about or you don't. And there's a signal associated with that we recognize in the laboratory, but we don't know what it looks like in the real world, where you're walking around, where you're moving your eyes freely. And something like OpenBCI gives you a chance to see what those signals look like in the world where you really want to use them.
Currently, brain-computer interfaces, they have a lot of amazing implications. It's just that not enough people are using them. And so our mission is to not only sell a product, but teach people how to use this product and host hackathons and meetups and share knowledge about brain-computer interfacing.
So thanks, Kickstarter. We really hope that you support our project.